Now we are going to discuss the problems on the chapter Mathematical Induction, which is the second chapter of 1A, Mathematical Induction. 1A, second chapter. Mathematical Induction. According to IPE, the weightage of this chapter is 7 marks, that is one long answer question, LAQ, only one 7 marks question. Mathematical Induction. In this chapter, main purpose of this chapter is we prove the given statement by using the principle of finite mathematical induction. We prove the given statement for all small n belongs to capital N, that means natural numbers. For all small n belongs to capital N by using the principle of finite mathematical induction. పరిమిత గణితానుగమన సూత్రము లేదా నియమము, దీనిని ఉపయోగించి సహజ సంఖ్యలకు సంబంధించినటువంటి సూత్ర నిరూపణ ఈ చాప్టర్లో ఉంటుంది. In this process, to prove the given statement by using this finite mathematical induction, majorly we have 3 steps. Step 1, that is we have to prove the given statement. Suppose that S of n be the given statement. Given statement S of n for S of n is true for n is equals to 1. Step 1 is we have to prove the given statement S of n is true for n is equals to 1. n is equals 1 ki ఇచ్చిన స్టేట్మెంట్ S of n అనేది నిజం అవుతుంది అని నిరూపించడము స్టెప్ 1. నెక్స్ట్ Step 2, we assume that given statement S of n is true for n is equals to k. n is equals to k. So in this step 2 లో వచ్చేసి ఇక్కడ మనం ప్రూవ్ చేయవలసిందంటూ ఉండదు. అజ్యూమ్ దట్ S of n is true for n is equals to k. డైరెక్ట్గా S of n అనేది n is equals k కి నిజం అవుతుంది అనుకుంటాం. అజ్యూమ్ దట్ S of n is true for n is equals to k. And the last step, that is the third step, step 3 is we have to show given statement S of n is true for n is equals to k plus 1. First step, to prove S of n is true for n is equals 1. Second step, assume that S of n is true for n is equals k. Third step, we prove S of n is true for n is equals to k plus 1. By using these 3 steps, we can conclude that the given statement is true for all n belongs to n. For all n belongs to n, given statement is true. ఈ 3 steps ఉపయోగించి ఇచ్చిన స్టేట్మెంట్ లేదా ప్రవచనం అనేది ఫర్ ఆల్ n బిలాంగ్స్ టు n, స్మాల్ n అనే అన్ని సహజ సంఖ్యలకు నిజం అవుతుంది అని చెప్పవచ్చు. సో ఇది మెయిన్ పర్పస్ ఆఫ్ దిస్ చాప్టర్ మ్యాథమెటికల్ ఇండక్షన్. ఈ చాప్టర్ యొక్క ముఖ్య ఉద్దేశం ఇచ్చిన ప్రవచనాన్ని ఈ 3 స్టెప్స్ ఉపయోగించి నిరూపించడము. హౌ కెన్ వి సే ఆర్ వి కన్క్లూడ్ బై యూజింగ్ ఓన్లీ దీస్ 3 స్టెప్స్ ఇట్ ఈస్ ట్రూ ఫర్ ఆల్ n బిలాంగ్స్ టు n. ఓన్లీ ఈ 3 స్టెప్స్ యూజ్ చేయడం ద్వారా అన్ని విలువలకు ఎలా నిజమవుతుంది అని చెప్పవచ్చు అంటే, I take an example here, just a cycle stand example. In a cycle stand, if we push one cycle, then automatically one by one will fall down. All the cycles in a cycle stand will fall down by pushing only one cycle. ఒక సైకిల్ని పుష్ చేయడం ద్వారా మిగిలిన అన్ని సైకిల్స్ కూడా వన్ బై వన్ ఒకదాని వెంట ఒకటి పడిపోతాయి. ఇన్ ద సేమ్ సెన్స్ అదేవిధంగా ఇక్కడ n ఈజ్ ఈక్వల్స్ 1కి మరియు n ఈజ్ ఈక్వల్స్ టు k+1కి నిరూపించడం ద్వారా రెండిటికి నిరూపించి దెన్ వీ కెన్ కన్క్లూడ్ దట్ ఇట్ ఈస్ ట్రూ ఫర్ ఆల్ n బిలాంగ్స్ టు n. ఒకటి పడితే మిగిలినవన్నీ పడతాయని ఎలా అయితే కన్క్లూడ్ చేయగలుగుతున్నామో ఈ రెండిటికి నిరూపించడం ద్వారా మిగిలిన అన్ని విలువలకు కూడా నిజం అవుతుంది అని చెప్పగలుగుతాము. దట్ ఈస్ ద మెయిన్ పర్పస్ ఆఫ్ దిస్ చాప్టర్ మ్యాథమెటికల్ ఇండక్షన్. నౌ వి గో ఫర్ ప్రాబ్లమ్స్. Now the problem number 1, using the principle of finite mathematical induction, using the principle of finite mathematical induction, using the principle of finite mathematical induction, prove that one into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus so on plus up to n terms. Prove that 1 into 2 into 3 plus 2, 3, 4 plus 3 into 4 into 5 plus so on up to n terms is equals to n into n plus 1 into n plus 2 into n plus 3 by 4 for all n belongs to capital N. Solution. It is in 3 steps. So first let S of n be the statement. ఇచ్చిన ప్రవచనమును S of n గా కన్సిడర్ చేసుకున్నట్లయితే let S of n be the statement. So I write S of n is 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus so on up to n terms is equals n into n plus 1, n plus 2, n plus 3 by 4 for all n belongs to n. Here before to go step 1, 2, 3, first we have to find nth term of the given series. Nth term of the given series. If we observe the given series, it involves 3 series again. ఇందులో మరలా 3 series 3 శ్రేణులు ఉన్నాయి. సో అవి ఒక్కొక్కటిగా సెపరేట్ చేసినట్లయితే ఫస్ట్ సిరీస్ ఈజ్ 1, 2, 3 so on. 1, 2, 3 so on, first series. Next second series 2, 3, 4 third series also 3, 4, 5, so on. So individually we find nth term and then we write in place of nth term of the given series. So if we observe these three series, all are in which progression? Arithmetic progression. 1, 2, 3, so on are in AP. 2, 3, 4, so on also in AP. 3, 4, 5 also in AP. Nth term formula, if the values are in arithmetic progression, Tn is equals to a plus of n minus 1 into d. Here a, in this series first term small a is equals to 1 plus of n minus 1 into d, difference, that is 2 minus 1, t2 minus t1, t3 minus t2. So 2 minus 1, 1, 3 minus 2, 1. That's why difference d is equals to 1. By the simplification we get 1 plus n minus 1 plus 1 minus 1 cancel is equals to n. In the first series 1, 2, 3, so on, the nth term is n. Next, second series 2, 3, 4, which is also in AP. Then the nth term is Tn is equals, same formula, a plus of n minus 1 into d. Here the first term a, small a is equals to 2 plus of n minus 1 into difference d, again 1, 3 minus 2, 1, 4 minus 3, 1. So that's why 2 plus n minus 1 into 1, n minus 1 is equals n plus 2 minus 1, so n plus 1. So in the second series, the nth term is n plus 1. Okay. Now we go for third series. Again, nth term Tn is equals. In this series, the first term small a is equals to 3. 3 plus of n minus 1 into d. D is equals, again 4 minus 3, 1, 5 minus 4, 1. So here also n minus 1 into 1. 3 plus n minus 1 into 1, n minus 1, n plus 3 minus 1 plus 2. Now the nth term of the given series, nth term of the given series Tn is equals, first product 1, 2, 3, nth term n into second series nth term n plus 1 into n plus 2. Nth term of the given series n into n plus 1 into n plus 2. Now the statement S of n becomes S of n up to n terms. Nth term place lo ee value substitute చేసినట్లయితే 1, 2, 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus so on plus. Now we write the nth term n into n plus 1 into n plus 2 is equals, given RHS value, n into n plus 1, n plus 2 into n plus 3 by 4 into n plus 1 into n plus 2, n plus 3 by 4. Okay. Now we go for step 1. Step 1, we have to prove S of n is true for n is equals to 1. n is equals 1 ki S of n అనేది నిజం అవుతుంది అని నిరూపించడం స్టెప్ 1 గా కన్సిడర్ చేసుకుంటాము. సో దట్ ఈస్ నథింగ్ బట్ we have to show LHS of S of 1 is equals to RHS of S of 1. n is equals 1 కి S of n అనేది నిజం అవుతుంది అని చెప్పడానికి మనం ప్రూవ్ చేయవలసింది LHS of S of 1 is equals to RHS of S of 1. These two values must be equal. ఈ two values కూడా equal గా ఉండాలి. For that, first LHS of S of 1. LHS is n into n plus 1 into n plus 2. In this, we put n is equals to 1. Okay, 1 into 1 plus 1 into 1 plus 2. 1 into 2 into 3, that is 6. LHS of S of 1 is equals to 6. Now we go for RHS. RHS value observe చేసినట్లయితే RHS of S of 1 is equals to, we put n is equals to 1 in the given statement RHS, n into, that is 1 into 1 plus 1 into n plus 2, that is 1 plus 2. Next n plus 3, 1 plus 3 by 4, which is 1 into 2 into 3 into 4. By 4. Product 1 into 2 into 3 into 4. 24 by 4, which is equals to 6. So now we can conclude that since LHS of S of 1 is equals to RHS, we can conclude that S of n is true for n is equals to 1. S of 1 యొక్క LHS value, at the same time S of 1 యొక్క RHS value రెండు ఈక్వల్గా ఉన్నాయి కాబట్టి S of n అనేది లేదా ఇచ్చిన స్టేట్మెంట్ n is equals 1 కి నిజం అవుతుంది. S of n is true for n is equals to 1. Step 1 is over in the process of using finite mathematical induction. Now step 2, which is also called as inductive hypothesis. Step 2 is also called as inductive hypothesis. Why means in this step we assume that S of n is true for n is equals to k. అందులోనే ఉంది assume that S of n is true for n is equals k. n is equals k కి నిజం అవుతుంది అని అనుకుంటాం కాబట్టి ఈ స్టెప్ని మనం ఇండక్టివ్ హైపోథెసిస్ ఊహా స్టెప్గా చెప్పుకోవచ్చు. స్టెప్ 2, we assume that S of n is true for S of n is true for n is equals to k. So substituting n is equals to k on both sides of the given statement S of n. S of n లో ఇరువైపులా n is equals k ప్రతిక్షేపించగా S of, it implies n is equals to k. S of k 1 2 3 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus so on, plus here also n is equals k into k plus 1, n is equals k. Next n plus 2, k plus 2 is equals to n into n plus 1, n plus 2, n plus 3 by 4. that is k into k plus 1 k plus 2 into k plus 3 by 4. Let it equation number 1. Step 3, which is also called as inductive step. Inductive step. In this step, we prove the given statement S of n is true for n is equals to k plus 1. In the above step, we assume that S of n is true for n is equals to k. Now we prove S of n is true for n is equals to k plus 1. It is enough to show మరి n is equals k plus 1 కి నిజం అవుతుంది అని నిరూపించాలి అంటే ఏమని నిరూపించాలి? It is enough to show S of k plus 1 plus 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus so on. Once again, substituting n is equals k plus 1 on both sides. K plus 1 into k plus 1 plus 1, that is k plus 2 into k plus 1 plus 2, k plus 3 is equals to k plus 1 into k plus 1 plus 1, k plus 2 into k plus 1 plus 2, k plus 3 into k plus 1 plus 3, k plus 4 by 4. ఇది మనకి రావాల్సినటువంటి వాల్యూ. ఇట్ ఈస్ ఎనఫ్ టు షో ఈ వాల్యూ రావాలి. టు ప్రూవ్ దిస్ we add the k plus 1th term on both sides of equation 1. Equation 1 కి ఇరువైపులా adding k plus 1th term, k plus 1వ పదాన్ని కలుపగా adding k plus 1th term which is denoted by tk plus 1, k plus 1th term tk plus 1 is equals to, how can we find tk plus 1? Just substitute n is equals to k plus 1 in the given statement. Given statement LHS we put n is equals to k plus 1. Adding tk plus 1 is equals k plus 1 into k plus 2 into k plus 3 on both sides of equation 1. Equation 1 కి ఇరువైపులా k plus 1th term ని కలుపగా. Equation 1 is 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus so on plus k plus 1, k plus 2. Now we add the term k plus 1 term ni కలుపగా ఏంటది k plus 1, k plus 2, k plus 3. On both sides ఇరువైపులా అని చెప్పుకున్నాం కదా. సో ఈక్వేషన్ 1 కి ఇరువైపులా ఈక్వేషన్ 1 RHS k into k plus 1 into k plus 2 into k plus 3 by 4. Now adding k plus 1 term plus k plus 1, k plus 2, k plus 3. Okay, now the simplification part on RHS. RHS ని సూక్ష్మీకరించినట్లయితే here the common value k plus 1 into k plus 2 into k plus 3 common, then we get k by 4 plus 1, k by 4 plus 1. So k plus 1 into k plus 2 into k plus 3 into LCM, taking LCM 4 k plus 4. So just we can write it as k plus 1 into k plus 2 into k plus 3 into k plus 4 by 4. Okay. If you observe this, it is enough to show ఏమని నిరూపించాలనేది ముందుగానే చెప్పుకొని ఉన్నాము. 1 2 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus k plus 1 into k plus 2 into k plus 3, okay, is equals to k plus 1, k plus 2, k plus 3, k plus 4 by 4. Clear? So S of n, therefore S of n is true for S of n is true for n is equals to k plus 1. Hence, now we can conclude that by the principle of finite mathematical induction, S of n is true for all small n belongs to capital N.